Okay, now let's look at a bunch of solving equation problems that are quadratic. So we have x squared plus 4x equals 12, and the key to solving a quadratic equation is to set it equal to 0. And so we want to have, on top of it being set equal to 0, we want to have the coefficient on x squared positive. So we'll do that by subtracting 12 over to the other side. Take away 12 from both sides, and we'll have x squared plus 4x minus 12. We want to write it in decreasing order of power on x. And let's see if we can factor. Maybe it's solved by factoring. Maybe it's not factorable. But let's try at least. If it's going to be factorable, we at least know the following. The fact that it's an x squared means that we're going to have an x and an x for our two binomials. The fact that that's a negative 12 means that the signs are different for the terms that go in these two spots. So we can have one as a plus and one as a minus. And then we have to solve a little riddle. We have to find the answer to this riddle. Give me two numbers that multiply to negative 12 and they add up. When we combine the middle terms, they add up to 4. And the answer to that riddle, that's supposed to be an M, sorry about that. Something's wrong with my tablet here. Oh my gosh. So the answer to the riddle is a negative 6 and a positive 2. So the 6 would go here and the 2 would go there. And it factors correctly. We're not done yet though. We have two terms multiplied to give me 0. Either the one is 0 or the other is 0. So the final answer is what x is, and we have two options. X could be negative 2 and x could be 6. That solves that one. Over here the same thing, but instead of taking the x squared over to the right, we're going to take these two terms over to the left with the goal in mind of keeping the coefficient on x squared positive. So I have x squared minus the 2x minus the 8 is equal to 0. Let's see if we can factor. It's x squared, so I'm going to have an x and an x. Now we have the issue of that the signs are different. With a negative in front of the constant term, the signs are different. One's going to be plus, the other's going to be minus. In this case, we can go ahead and put them in because these guys won't look any different. We can interchange them. And now the riddle is, give me two numbers that multiply to be a negative 8, but when we add them up, we get a negative 2. And the answer to that riddle is a negative 4 and a positive 2. And so the 4 would go here and the 2 would go there. Not done yet. Either x plus 2 is 0 or x minus 4 is 0. That's not why you're going to have a product equal to 0, is if one or the other part of the product is equal to 0. So on the one hand, x is negative 2. On the other hand, x could possibly be 4. Okay, great. So what made those so easy is that the coefficient on x squared was a 1. We don't have that on these next two. And so we have this quadratic here, but we notice that, okay, it's not in decreasing order, and there's a negative in front of the x squared. So let's basically just ship everyone over to the left-hand side. That way we'd have exactly what we want, set equal to 0, and at the same time, the coefficient on the squared term is positive. So we have 2x squared, or 0 equals 2x squared minus 5x minus 3. Maybe we can factor it, maybe we can't. Let's try it. 2x squared breaks apart as 2x and x. The signs are going to be different because of the minus in front of the constant. But when there's a coefficient other than 1 in front of x squared, then we can't just haphazardly put the signs in like we did up here. The good thing about the 3 is that it only breaks apart as either 3 or 1 and 1 or 3. So either the 3 goes first and then the 1, or the 1 goes first and then the 3. Those are your only options. And it's going to be that the 1 goes first and then the 3, because we want to end up with a negative 5x. So we're going to have a negative 6x and a positive 1x to make it work out. And this is equal to 0. So either 2x plus 1 is 0, or x minus 3 is 0. Subtract the 1, divide by the 2. Here x is negative 1/2. Here x is 3. These are the two values that make that equation true. Let's try it again over here. Now we're going to run into a trouble with something like a 6 in front of the x squared. We have multiple ways that that could be broken apart. Not just as 6x and x, but also as 2x and 3x. So we could do trial and error, definitely. When you tire of doing that, there's other options. And so let's try this factor square business that we had talked about. It works like this. Make a square with 4 parts to it. And in the upper left corner, put the squared term. In the lower right corner, put the constant term. Multiply those guys together. 6 times a negative 20 is a negative 120. And then you have the same riddle that we have over here. I need two things that will multiply to give me 120 negative, and add to give me that middle term of negative 7. Now 120 is a large number, and so it's going to be not that easy to do, but just sort of work your way in. 1 and 120, 2 and 60, 3 and 40, 4 and 30, and here we go. Oh no, wait, 5 and 20, what is that, 4? Yeah, 5 and 24. 6 and 20. We need them to combine to be a 7. So we need to keep going. And it's going to be 8 and 15. Sorry. Finally got there. There's a few other factors, but this is the ones that will combine to be a 7. Okay? Well, how's it going to be a negative 7? It better be a negative 15 and a positive 7. A positive 8, I'm sorry. That's the answer to the riddle. So what do you do with these? We put them in here. Negative 15x and a positive 8x. And then you factor every row and every column, and then you're done. What do 6x squared and negative 15x have in common? A 3x. What do 8x and negative 20 have in common? A 4. What do 6x squared and 8x have in common? A 2x. And what do negative 15x and negative 20 have in common? A negative 5. And so that takes away the guesswork. And we have 3x plus 4 times 2x minus 5. And it'll work out. If you FOIL it out, you'll see that it works. Now, we want to solve the problem, and we have to then take each one of these separately and set them equal to 0. So either x is negative 4/3, subtracting the 4 and dividing by the 3, or x is positive 5/2, adding the 5 and dividing by the 2. Okay, and we'll come back with another video for the other 4 problems there, but on the next slide. But yeah, that's good.